Alright, so this video is going to go through section 1.3, and this is going to be complex numbers and their role with quadratics. So when you're doing the quadratic formula so far, underneath that square root, we've gotten a positive number. But in situations, sometimes you're going to get the square root of negative 16, and you can't do that. There is no number times itself that's going to give you negative 16, because a positive times a positive is a positive, but a negative times a negative is also a positive. So before now, this was not possible. But because it's math and we like to make things fun, we are now introducing something called imaginary numbers. What you need to know is that the square root of negative 1 is equal to I. So anytime you see a negative number underneath that square root symbol, you need to start thinking about using the letter I, because it's going to happen. It's now a complex solution. Now, you need to know that there's this pattern system when it deals with I. So I just told you that I was equal to the square root of negative 1. Now, if I wanted to do I squared, that means it is I times I, and I just told you that I was equal to the square root of negative 1, so this is the square root of negative 1 times the square root of negative 1. When you multiply two things with the square roots, what you're left with, and if they're the same, is just what's underneath it. So the square root of negative 1 times the square root of negative 1, that's just equal to negative 1. So I is equal to the square root of negative 1, and I squared is equal to just negative 1. Now you can do I to the third, which is I times I times I, which is the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Remember, when you have two of these together, it just translates to negative 1. So I have negative 1 times the square root of negative 1. But I told you that the square root of negative 1 was equal to something. This right here is equal to I. So I now have negative 1 times I, which is just negative I. So I cubed, or I to the third, is equal to negative I. And then I to the fourth is like 2i squared, so it's negative 1 times negative 1, and that's just equal to positive 1. So I'm telling you right here, it starts repeating. If I wanted to do I to the fifth, it would give me the square root of negative 1, or I. I to the sixth would give me negative 1. I to the seventh would give me negative I. And I to the eighth would give me positive. It would give me positive 1. So this is what I mean by the patterns of I. This is something that you want to memorize. Now I'm going to give you some examples of where we're going to use this. The first one, I want you to simplify or tell me what I to the 27th is. Now since there are 4 in the pattern before it repeats, what you're going to do is you're going to take that exponent and you're going to divide it by 4. So 27 divided by 4. I asked myself, how many times does 4 go into 27? It goes into there 6 times, and I have a remainder of 3. That remainder is what's really important, because that tells you which power of I you're looking at. So since it's a remainder of 3, I'm looking at I cubed. So I to the 27th is the same thing as I cubed, and it's equal to negative I. Another example is I to the 58th. So again, you're going to do 58 divided by 4. 4 goes into 58 14 times, and it has a remainder of 2. So again, that 2 tells me that I to the 58th is the same thing as I squared, and I squared is equal to negative 1. So I to the 58th is equal to negative 1. Now you're not going to see this a whole bunch, but this is how you do it if it does come up. You'll see it in just a minute when we start doing operations with I. Now I'm just going to jump right into the three main operations with I, and I'm going to save division for last. So I'm going to do some addition problems, some subtraction, and multiplication. Division is a little different, so we'll save those and do those in just a second. So the first example I'm going to do is 8i minus 4 plus 3 minus 2i. So I want to look and kind of treat these like variables in the beginning. I need to see whatever I can combine with this 8i. So in order to combine it with it, it also has to have an I. So that means I can't use the minus 4 or the plus 3, but I can do the minus 2. So 8i minus 2i leaves me with 6i. Now I look at the minus 4, and the only thing I can combine with it is the plus 3. So negative 4 or minus 4 plus 3 leaves me with a minus 1. Now I can't combine those any further, so this would be your answer. Number 2, I have parentheses here. So in the first parentheses, 6i plus 10 plus the second parentheses was just 2i minus 8. Now that plus in the middle means that no sign changes happens in the second parentheses. So I'm going to have plus 2i minus 8. So just like the first problem, I'm going to combine my like terms. So 6i can be combined with 2i, and that will give me 8i. And then I can combine this 10 with this minus 8, and 10 minus 8 does give me a positive 2. Now, the next two examples, we're going to do parentheses, but they're going to have something special about them. So I'm going to do 4i plus 7 minus 6i minus 3. Now, in example 2, I had the parentheses there, but it's a positive in the middle, so nothing changed. Here we have a negative, so we have to distribute that negative. What that means is we're going to multiply. I don't do anything with the 4i plus 7, but I do end up having to do the step of negative, and there's a 1 here if nothing's there. Negative 1 times 6i, that changes it to a negative 6i, and I do the same thing with the negative times a minus 3. So negative times a negative gives me a positive. Now I can start combining my like terms. 4i can be combined with minus 6i, so 4 minus 6 gives me a negative 2i. And then I can do the same thing with this positive 7 and the positive 3. When I combine them together, I get a positive 10. Now number 4, in the first parenthesis, I have negative I plus 8, and then minus parentheses negative 2i plus 1. So I don't do anything with the first parenthesis except bring everything down. So I have negative I plus 8. But now I'm going to distribute this negative into the parentheses. So a negative times a negative gives me a positive 2i. And then a negative times a positive gives me a negative 1. I got rid of the parentheses, so now I can start combining like terms. With this negative I can combine it with the 2i. So that's like negative 1 plus 2 or 2 minus 1. And that just leaves me with I. And then I have a positive 8 and a minus or negative 1. And 8 minus 1 leaves me with a positive 7. So the next ones I'm going to do are multiplication. And these are ones where you have to kind of do your distributing, your FOIL process. What that means is we're going to multiply everything by everything. So negative 3 times negative 6, that gives me a positive 18. Negative 3 times negative 8i gives me a positive. I multiply the numbers, 3 times 8, 24, and then don't forget the I. Now I'm going to multiply 2i times negative 6, so that gives me a negative 12i. And my last step is 2i times negative 8i, so that gives me a negative 2 times 8 is 16, I squared. Now I can start combining stuff, but what I do need to do first is get rid of this I squared. I told you in the patterns of I that I squared is the same thing as negative 1. So I'm going to rewrite everything. I have 18 plus 24i minus 12i minus 16, and instead of I squared, I'm going to write negative 1. So I have 18 plus 24i minus 12i, and now I have negative 16 times a negative 1. That brings me to a positive 16. I can now combine my like terms. I can combine 18 and 16 together, and when I do that, I end up with 34. I can do the same thing with 24i minus 12i, and that leaves me with a positive 12i. And this right here would be your final answer. Now, this is number 6, another problem, and it's 1 minus 7i squared. And now you may be tempted to just square everything inside, but that's not right. That's illegal math. You need to rewrite this as 1 minus 7i times 1 minus 7i. And now we start FOILing or distributing everything to each other. So 1 times 1 gives me a positive 1. 1 times negative 7i gives me negative 7i. Negative 7i times 1 is another negative 7i. And then negative 7i times negative 7i gives me a positive 49i squared. So just like the last example, I need to replace that I squared. So I'm going to write everything else. And I have plus 49, and instead of I squared, you have a negative 1 or a minus 1. I have 1. I'm going to combine these two, the negative 7i minus 7i, and it's going to be negative 14i. And then positive 49 times negative 1 is negative 49. Your last step, I can combine this 1 and this negative 49. And when I do so, I still have negative 14i, but 1 minus 49 leaves me with negative 48. So these next ones that I'm going to be doing are when you have I in the denominator of the fraction, and that's something we cannot have. So the first step here is to multiply by its conjugate. And what that means is we're going to turn the imaginary part into the opposite. So if the imaginary part is positive, it's now going to be negative. If it's negative, it's going to go positive. So when I look at this problem in the denominator, it only has one part here, and the opposite of that imaginary part is going to go to 5i. So I'm going to multiply this original problem by 5i over 5i, because that would be 1 and it doesn't change the problem. So when I do that, I have 5 times 5i, which is equal to 25i over, I now have negative 5i times 5i, and that gives me a 25i squared. Now we've talked over and over again what I squared stands for. So on top I still have 25i, but on bottom I have 25 times I squared gives me negative 1. And sorry, you still have a negative there in front. Now on top I have 25i over negative 25 times negative 1 gives me 25. I'm going to simplify this. If you have that fraction button, if you have that calculator we asked for, above the 7 is a fraction button, and you can plug in these numbers to see if they reduce. 25i divided by 25 actually just gives you I as your answer. So if you were to simplify number 7, your answer would be I. So number 7 was like a baby problem, so we're going to actually get into these more difficult problems now. So I told you the first thing you needed to do was to see if there's an I in the bottom, and there is. So what we need to do is we need to look at the imaginary part, which is the minus 3i, and we're going to change its signs. So we're now going to have 2 plus 3i. And remember, whatever you put on the bottom, you have to put on the top because we don't want to change the problem. I'm going to multiply this straight across, and I'm going to write it a little differently here because we have 2 parts. So I have in my first parenthesis I times 2 plus 3i, and on the bottom I have 2 minus 3i times 2 plus 3i. Now I'm just going to start multiplying everything. So I times 2, that gives me a 2i, and then I have I times 3i, and that gives me a plus 3i squared. I'm going to do the same thing with the bottom. So 2 times 2, that's going to give me 4. 2 times 3i is going to give me a positive 6i. Negative 3i times 2 is going to give me a negative 6i. And finally, negative 3i times a positive 3i gives me a negative 9i squared. This next step that I'm going to do is I'm going to get rid of those I squareds. So 2i plus 3, and instead of I squared, remember, we're going to write negative 1. Now on the bottom, I'm going to do one other step as well. I'm going to have 4 plus 6i minus 6i minus 9, and in parentheses instead of I squared, again, you're going to put that negative 1. But if you look here, I have this positive 6i minus 6i. What happens is this goes away completely. So if I simplify further in the top, I have 2i, and I have a positive 3 times a negative 1, so minus 3, over, you have 4, and you have negative 1 times a negative, or negative 9 times negative 1, sorry. So it's a positive 9. We can simplify just a little bit further, and I have 2i minus 3 over 13. Now I am going to split this fraction into two parts, the real part of the answer and the imaginary part. So all you do to write that fraction is you put the first part over the denominator. So you have 2i over 13, and do the second thing with the second one, sorry. And since it's minus, I'm going to go ahead and put that minus sign in between, and you have 3 over 13. Remember, to write it properly, we put that real part first, so 3 over 13, and since it is a minus, it will be a negative 3 over 13 plus 2i over 13. When you do the conjugate, when you multiply that by the conjugate, something should cancel out like this. You should not have any i's left in the bottom. If you do, then you did something wrong and you need to look at your work. Remember, the conjugate is when you take that imaginary part of the answer and you just change its signs. So I'm now going to multiply this by 10 minus 5i on the bottom, and the same thing on the top, 10 minus 5i. I'm just going to multiply straight across, so I'm going to rewrite this as the first parentheses, 10 times 10 minus 5i, over, I have 10 plus 5i times 10 minus 5i. And now we can start distributing and foiling. So 10 times 10, that gives me 100. 10 times negative 5i leaves me with negative 50i. So that's what the top of my fraction looks like. Now when I start multiplying on the bottom, again, I have 10 times 10, so that's 100 again. I have 10 times negative 5i, so negative 50i. 5i times a positive 10 gives me a positive 50i. And then finally, 5i times negative 5i is negative 25i squared. So first thing I want to look for is if something canceled out in the bottom, and it does. I have that negative 50i and the positive 50i, so that's going to go away. So what's left in my fraction on top is 100 minus 50i over 100 minus 25, and instead of I squared, remember you have negative 1. So I now have 100 minus 50i on top over 100. Negative 25 times negative 1 is a positive 25. I have 100 minus 50i still on top over 125. And now we break it apart in two again. So I have 100 over 125 as my real part of this answer, minus my imaginary, which is going to be 50i over 125. Now these fractions do reduce, so again, if you have that calculator above the 7, you can put each of these in separately. You can put 100 over 125, and that will leave you with 4 over 5, minus, you could put 50 over 125, and that will give you 2i over 5, and this is your final answer. The last topic I am going to hit on this is a quadratic formula. We've done that in another video, but what I'm going to be doing here are examples that have imaginary or complex solutions. So the first example I'm going to do is 4b squared minus 3b plus 2. And remember, your quadratic formula looks like this. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So just like before, the first thing I want to do is figure out what my a, my b, and my c are. So in this case, my a is 4, my b is negative 3, and my c is 2. I'm going to go ahead and start plugging those into the formula. So the opposite of b right now is negative 3. So the opposite of negative 3 would be positive 3 plus or minus the square root of b squared, which is negative 3 squared, minus 4 times a, so 4 times 4, times c, which is 2, and it's all over 2 times a, which is 2 times 4. We now start simplifying, so I have 3 plus or minus the square root of 3 squared, or negative 3 squared is negative 3 times negative 3, which is 9. And I have negative 4 times 4, which is negative 16, times 2, which is negative 32. And it's all over 2 times 4, which is 8. So now I have 3 plus or minus the square root of 9 minus 32 gives me a negative 23 over 8. Now I have that negative number underneath the square root, and I can't do that. What that means is I have 3 plus or minus, I have the square root of 23 times the square root of negative 1. All I did was pull out that negative, and it's still over 8. Now we just talked all about imaginary numbers, so I know this is now 3 plus or minus the square root of 23, and instead of the square root of negative 1, you need to write I over 8. Now I can't divide all 3 of these or all the 2 on top by 8 or any of them by the same number, so I would leave it. What you need to be careful of is this radical right here. You want to plug this into your calculator to see if it simplifies, but this one doesn't. So I could leave my answer like this, or if I wanted to split it apart into the 2, it'd be 3 plus the square root of 23i over 8, and 3 minus the square root of 23i over 8. And again, you split these into 2 again. So you have 3 over 8 plus the square root of 23i over 8. Your real and your imaginary, and same thing with the second one. 3 over 8 minus the square root of 23i over 8. So here would be your 2 answers for x, or whatever the variable is. So the second example I'm going to do is x squared minus 6x plus 12. I'm going to list out my a, my b, and my c again. A here is 1, b is negative 6, and c is 12. Plug it into the quadratic formula. The opposite of b would be 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 times a, which is 1, times c, which is 12, all over 2a, which is 2 times 1. I start to simplify, so I have 6 plus or minus the square root of negative 6 squared, or negative 6 times negative 6 is 36. Negative 4 times 1 is negative 4, times positive 12 gives me negative 48. And it's all over 2 times 1, which is just 2. 6 plus or minus the square root of 36 minus 48 gives you a negative 12 on the inside over 2. Remember, we're going to take that negative out, so I now have 6 plus or minus the square root of 12. And we took out the square root of negative 1, so you put your I on the outside over 2. Now, the square root of 12 does simplify, and it simplifies to, instead of the square root of 12, your calculator will give you 2 square root of 3i, and you have it over 2. Now, I can divide both of these parts, 6 and 2 square root of 3 over I, by 2, so I'm going to do that. 6 divided by 2 gives me 3. I still have my plus or minus. And 2 square root of 3i divided by 2, your 2's just cancel out, and I'm left with the square root of 3i. Now, when I separate this into 2 answers, my first one is 3 plus the square root of 3i, and my second one is 3 minus the square root of 3i. So you have to be careful with those negatives under the square root. All you do is leave the number the same, and then pull the I to the outside.